Minimum time to reach a point in offshore. A pair of scuba divers wishes to dive on a wreck that lies 0.4 kilometer off the shore from a point 0.8 kilometers from their present position. If they can walk carrying their gear at 5 kilometers an hour and swim at 3 kilometers an hour, what course should they follow to reach the wreck in minimum time? So let's try to sketch this position like this. Let's say this is the shoreline and we have a wreck somewhere at this point. So let me just draw a line here, and this point happens to be 0.4 kilometers from the shore. So let's say that's the point, and this is 0.4 kilometers off the shore. So from here the distance is 0.4 kilometers. Now at present our scuba divers are somewhere at this point, which is 0.8 kilometers from that. Okay, so this is 0.8 kilometers. Now they have an option, they can go straight there, correct? That is one option. This is also possible that they can just go straight, dive in and go straight. The second option could be that they walk for some time with all their gear like this and then swim. So that's the option. So these are the two options, and they can walk as long as they want and then they can swim to get across. Now the idea is at which point should they swim towards the wreck so that they get the minimum time. This is what we need to figure out. Let us say that is the critical point and its distance from here is, let us say, x. In that case, the walking distance will be 0.8 minus x, correct? And the swimming distance will be this part. So this part will be the swimming distance. How much will that be? That we can find with Pythagorean theorem, which will be x square plus 0.4 square root. So this is going to be the swimming distance. Now the time taken for them will be distance divided by speed, right? So distance is this much and the speed is the walking speed during this time. Walking speed is given to us as 5 kilometers an hour and the swimming speed is given to us as 3 kilometers per hour. So that gives us the time. So we get a function time in terms of this distance x, from where we can find, with the help of derivative, the minimum time. That's the approach, right? So let's start our work. So we say time t, so let me use time t, is equals to the walking distance, which is 0.8 minus x, over distance is this much and speed is 5 kilometers an hour, so I'll divide this by 5, plus swimming time. So the distance for swimming is square root of x square plus 0.4 square divided by the speed they can swim, which is 3. So that gives you time as a function of distance. So this is the most important thing. Once we have this, we can find dt over dx and then equate it to 0 to find our minimum, right? So dt over dx will be, in this case, we have this particular function, so the derivative of this is minus 1 over 5, this first part, and here what do we get? Plus, this is 1 over 3, let me write 1 over 3, this is something to the power of half, that gives you half times the same thing, which is x square plus 0.4 square to the power of minus half, times derivative of inside function, which is 2x. So that's what you get. Now we can write it as minus 1 over 5, right? And here we have 1 over, now this 2 and 2 will cancel, correct? So we got 3 here, and that comes in the denominator. We get plus, in the numerator we have x, in denominator we have 3, square root of x square plus 0.4 square root. Now for minimum or maximum, or rather critical point, dt dx should be 0. So let's equate it to 0 and find that critical point. So we are trying to find critical point now. Okay, therefore we equated this to 0, right? This is for critical point. Now when you equate this to 0, you can take it on this side and then multiply by 3. So we'll do cross multiply and then simplify, right? So we get an equation which is Now the denominator here, so let's do it in steps. We get 1 over 5 equals to x over 3 square root of x square plus 0.4 square is 0.16. To solve this, let's take it, let me not do it on this side. So we'll cross multiply and solve for it. So we get 3 times square root of x square plus 0.16 equals to 5x. So that is our square equation. Let's square both sides to get rid of the square root. Whenever we do square, we do incorporate errors. Okay, remember that. So when you square it, you get 9 here, and here we get x square plus 0.16, and here we get 25x square. Now you can bring x's together and get your answer. 9x square, 25x square. So we'll, and 9 times, so we get 9 times, let me write 9 times 0.16, and on this side we'll do 25x square minus 9x square, correct? Now 25x square minus 9x square is 16, and so we get 16x square, and on this side let us keep it as 9 because all are perfect squares fortunately for us, so it's good to keep them like this. Now let's square root and divide by 16, correct? So let me move further. Yeah. So when we square root, we get x on this side. Let me write x here equals to square root of 9 is 3 and 0.16 is 0.4. So we get 3 times 0.4 and we divide by 16 square root, which is 4. So that is the value of x, correct? So the idea is here very good values are given to us. They really are so simple that it helps. We don't have to use calculator. So we get 3 times 0.4 divided by 4. So that goes 0.1 times, and you get x equals to 0.3 as your answer, right? So x equals to 0.3 is your critical point. Now you need to figure out whether at this point you get a maximum or minimum. That is one way of doing it. The other way of doing this is by taking the extreme values. Extreme values means that, as you can see from here, what could be the value of x? That is the boundary conditions. So you know x could be greater than equal to 0 and less than equals to 0.8. So these are the possible values, right? So these are the possible values for x. So if x is 0, that means they will walk up to this point and then swim. If x is 0.8, that means they just straight go for swimming, right? So these are the two values. Now what we should do is find the value of function which is t for these two values and the critical point 0, 3. Right? So find out the answer. What is, I should write t of 0 instead of writing f because we have defined function t, and now this is like t of x, correct? So let's find what is t of 0 equals to, and then what is t of 0.8 equals to, and what is t of 0.3 equals to. Plug in the values and get your answer. Once you do that, you can get the minimum time, and you'll get the minimum time for x equals to 0.3. Good. So that is the minimum time, 0.3, right? Now that will be your answer, right? So what course should they follow to reach the rect in the minimum time? So they are very interested in which course to follow. So the course will be, they'll have to walk down up to this point, which is, so they walk for 0.8 minus 0.3. So they walk for 0.8 minus 0.3 is 0.5, half kilometer. So walk half kilometer, right? Then swim. So that should be the answer, right? But I'm leaving this exercise for you to do, how much time really it takes. So when you plug in 0 here, this will be 0, this will be 0, calculate your answer. Then you plug in 0.8, the whole fraction will be 0 here, you can calculate this. And then plug in 0.3 and check for yourself. That will be your minimum time. And therefore, The answer for us will be that they are going to walk from here to here half a kilometer. Half a kilometer corresponds to x equals to 0.3. That is how we get half a kilometer. Plug in 0.3 for x. 0.8 minus 0.3 is 0.5. Correct. So that is half the kilometer and then this swim. So that is going to be the answer. I hope that is clear, and I hope don't mind doing this calculation on your own. Thank you and all the best.